Thank you for elaborate introduction. And also thank you, Dr. N. Kalachalvi, for inviting me for this uh, CSIR AMRIT lecture. I'm honored to give this, whatever I know presently, what are the opportunities are available in ocean, as well as a scientific community, what are the challenges we are facing with the ocean. So just I will share some of the glimpses of what are the opportunities and challenges, and maybe not deep into the subject, and maybe the subject not into the deep ocean, but I will be shallow ocean I will be talking about. So I'll be talking about just the importance of ocean. Just very already, Madam also told that what are the importance of the ocean highlighted. You have given the abstract, and maybe I will just to talk about, mainly I will talk about the opportunities in the major thrust areas of food, water, energy, and what are the opportunities available in the ocean. And also there are major challenges, especially what are the challenges of climatic as well as non-climatic stresses which is taking place over the ocean and how we have to tackle. And lastly, I will just point out about the way forward. And finally, I will just tell about the glimpses about the Deep Ocean Mission. Deep Ocean Mission is the basically a pilot project of major blue economy project which is yet to come. So this is a prelude for the blue economy, which we are planning to go for interministerial uh, project. So before going to ocean, maybe I will just point out about the Ministry of Earth Sciences. Many of the people may be knowing. Of course, it is we are looking at 5 spheres. We are looking holistically. We look at the atmosphere, hydrosphere, geosphere, cryosphere, and associated biosphere, how holistically interact with each other, and what is its impact on the Earth system. That's what we are looking at it. For that, we have about 10 institutions. The one major one is the India Meteorological Department. And along with that, there are two other institutions of Indian Institute of Tropical Meteorology, Pune, and National Center for Medium Range Weather Forecast in Noida. So these three institutions mainly look at the atmosphere. Then there are about 5 to 6 institutions, they look at the ocean. That is a Center for Marine Living Resources, Kochi. They look at only living resources. And then National Center for Coastal Research, they look at the coastal pollution monitoring as well as shoreline monitoring, how coast is changing over the time. And the uh, third one is Indian National Center for Ocean Information Services. Mainly they do most of the ocean observation, in situ observations, and also modeling, and thereby they provide various kinds of services to the society. And the last one is National Institute of Ocean Technology. So that is mainly to develop a technology for ocean related aspects. And also there is National Center for Polar and Ocean Research. That institute is unique because it is taking care of all 3 poles. That means Antarctic, Arctic, and Himalaya. That means solid state of water. It is how it is changing over the period, and what are the signs required for polar regions. So also they are trying to do some of the exploration of ocean resources, mainly in the non-living resources. How do we explore where it is available? Various minerals and metals are available. So they mainly they go and hunt where it is available, the resources. And the last two institutions, it is a National Center for Seismology. It is mainly monitor various earthquake where it is happening all over India. So as of now, we have more than few hundreds of seismometers. From that, we try to identify the earthquake wherever it is happening within India within 3 minutes, and if the earthquake is more than 3 magnitude. And the last institute is National Center for Earth Science Studies. It is from Thiruvananthapuram. Mainly, they look at the solid earth in terms of geology or geological history. Also, some of the coastal related aspects, they also look at it. So these are the various institutions working under the ministry. And our objective is mainly SQ, do science and translate that science to the services for the benefit of society. So this is the main focus for all the spheres. So we collect observation, convert to data, data to information, information to knowledge, then you go for services. That is our main focus in all the 5 spheres. So now I'll come back to dive to ocean. As you all know that oceans has oceans of opportunities. And if we start with it feeds us, you have a protein. The amount of protein available in the ocean is huge. Not only fish, you have seaweeds, and there are many other proteins are available in the ocean, so it feeds us. It regulates weather and climate. When you talk about when you want to forecast next few days, the memory is available only in the atmosphere. But beyond 10 days, you want to forecast next monsoon, how it will be, next season, how it will be, or next year, how it will be. So you have to dive in the ocean. If you have ocean memory, then only you will be able to forecast beyond 10 days. If your forecast beyond 10 days is good, you have to thank the oceanographer, not the meteorologist. If the forecast is good in next few days, then the meteorologist have to be thankful. So that's why this other one is a climate. See, when you're talking about climate, without ocean, there is no talk about climate because this is a climate regulator. The ocean is a whatever you put the heat, it is absorbing and it is releasing. So when you talk about climate, atmosphere will not tell the clue. Only climate. Each depth. Suppose you want next season or next year, how it or next decade or next century. When you want to have next decade, you have to go to 100-meter deep. When you want to go for 2-kilometer depth, then you can try to see what will be the next century. So that is the memory available from the ocean. So if you have a predictive value is available depending upon the different depths. And also, as a already Madam told that we have oxygen. Every alternative breath, what we are breathing, that has come from the phytoplankton from the ocean. So oxygen is available from the ocean. And also it is also largest sink, carbon sink, whatever it is going to the atmosphere, finally it is sinking in the ocean. So it is having largest sink in the earth. And also it is providing various other kinds of living as well as non-living resources for the mankind. And also it is tourism and recreation, the coastal tourism and coastal area. It is very, though India is, we are not much utilized. That is one of the challenges we need to tackle. The tourism industry we need to develop along the coast. And also maritime transport, it is shipping. 90% of the volume of the material transported, especially in India, it is through shipping. So volume, in terms of volume. So that means shipping, we need to take care. Why we have to take care? Because shipping, we need to improve. The Sagarmala and many other projects, I will slightly touch upon that. And then finally, we have to secure our coastal area security and coastal protection from natural and as well as man-made hazards. But so many opportunities are there, but still we have what we have understood very little, especially when you talk about deep ocean. We know only 5% of the deep ocean. Beyond, we don't know much about what is happening, physical process, chemical process, biological process, and what is happening, we don't know. So I think we need to know that that is one of the objectives which we have envisaged for the deep ocean mission to understand the deep. Actually, deep ocean mission is not meant for deep ocean to go and do research. No, it is a deep knowledge, deep thinking. Deeply, we have to look at ocean to understand better. That is what deep ocean mission. So under that, internationally also they felt these are the opportunity. So this is though ocean is 72% of the planet, but we have only so many SDGs. The SDG 14 is the least priority, and it has been the money-wise budget allocated to SDG 14 is very small when compared to all the SDG 14 SDGs. So I think it is very important. We need to have a sustainable development. More and more countries. That's what now we are advocating. SDG 14 has to be, each country has to give more money to develop this ecosystem. And also now this decade, 2021 to 2030, it is a UN decade of ocean science, basically sustainable development. Basically, we are looking at the science we need for the ocean we want. That's the objective. Under that, what we want to have at the end of 10 years, what are the science we need to do that we are building. Of course, this is one of the INCA's Hyderabad lab is one of the advocate, one of the important contributor to this decadal ocean. And for the Indian Ocean region, The in case Hyderabad is a decadal center for this region. And also, you know that Government of India's vision of New India 2030, the blue economy as one of the 10 core dimensions of the growth journey of our country. So that is what the opportunities of available in the ocean sector. At the same time, you can go seas of challenges. Why I put oceans of opportunity and seas of challenges is earlier it was oceans of opportunities were there and seas of challenges. But now it is reversed because of mankind, ourselves. So it is now oceans of challenges, but seas of opportunities are available. So we need to revert that. That is the main objective. In the challenges, mainly broadly, if you're talking about one is a climate stress, related to climate, surface temperature warming in the ocean, and sea level increase, marine heat wave, and also ocean acidification and hypoxia. So many related to the climatic stress is happening in the ocean. So we need to do what we need to do for that, what we need to observe, what we need to understand, then what are the remedial measures we need to do. That's what we have to think about it. And some of the things are non-climatic stress. It is a man-made or natural process. Suppose cyclone, it is always there. It is not only because of climatic effect, it is there. But the climate effect is modulated the cyclone. Maybe now the cyclones are more intensified than earlier. The cyclone is a natural process, but climate, because of the climate amplification, the intensity of the cyclone is increasing. And also we have a over exploitation, and there are many invasive species and marine litter, and also there are oil spill pollution and other things. So there are so many things are happening in the non-climatic stress. Apart from that, the many challenges is we need to understand better. As I mentioned, that we know only 5% of the ocean. So we need to understand better. For that, we need to have observations. For that, we need new technologies, and also we need. There are many resources available, both living and non-living. For that non-living and living resources to harness sustainably, we need a technology. Many places, many areas, we don't have a technology to harness the ocean sustainably. And also we don't have presently in India ecotourism and clean energy. We need to do promote in India in order to have economies better. And also we need to protect coastal areas because many areas are because of the sea level rise, especially in the east coast. Many places it has been eroded. You know that in Pondicherry earlier beaches were there. Now there is no beach, but now we are artificially creating the beach. But there are many things is going to happen. So we need to have a like town planning. We need to have a coastal planning. So coastal marine planning is an important aspect which we need to take care. That is one of the important challenge. And also we need to have a how to make a marine litter, marine pollution, how to avoid. We need to make awareness. Whatever has gone into the ocean, if the same thing continues, I think 2050 or so, the more marine litter than fishes. So it is very dangerous. So we need to tackle this effect. And also we need to have a strengthening our international cooperation. It is a strategic space. We can do a lot of geopolitics in this ocean. So we need to have more understanding, and also we need to have a security arrangement in the coastal areas. Finally, we need to build the capacity, especially the human resource. Human capital is ultimate resource which we need to build in the country. So these are some of the opportunities and challenges. But now in the opportunities, I will just highlight some of the major areas where we need to harness or where we need to attack. Before going to that, if you know that the Indian Ocean is very unique when compared to other oceans, because this is the only ocean where northern latitude is blocked by Indian landmass, Asian landmass. So whatever heat gained in the tropics, it is not able to transport it to the polar regions. So because of that, the tropical ocean is the warmest region. Indian Ocean, Indian tropical region, whatever the things, it is the warmest, and it is a trend also very highest trend in the Indian Ocean is facing. And this is the only ocean where the low latitude opening is there in the Indonesian through flow. Because of that, whatever the gain, heat gain in the Pacific, that all transported to Indian Ocean. So again, it is able to heat it up. Of course, I am talking about the physics part of it. There are biological part, then about what is called chemical part. There are a lot of uniqueness in the Indian Ocean. And this is the only ocean where or only North Indian Ocean, you have a reversal of currents. 6 months in the coastal currents from Calcutta to Chennai, one direction, in another 6 months, Chennai to Calcutta. So that is only possible, or it is a possible in the 6 months reversal, is happens only in the Indian Ocean. So whether we can make use of this reversal, that's one of the important aspects which we need to think about. It is not only East Coast, but also in the West Coast. Then only the leaving current, it is in Australia, it flows towards southward, whereas all South America or maybe South Africa, everywhere, if you see that the currents will be towards equator, but only the leaving current in Indian Ocean, it is towards the poleward. So these are some of the uniqueness. Because of that, there are very rich variability from synoptic scale, from intra-seasonal, interannual, decadal, centuries. All these scales are, there are very rich variability exists, but we have very less observation in 20th century. So now we are augmenting more and more observations in Indian Ocean to understand better as well as to predict better. And there are many other uh, resources to harness better. And coming back to Indian Ocean to India, if you see what are the opportunities again, we have fortunate to have 2.17 million square kilometer of EEZ resources and also long coastline. And we have 12 major and 200 minor international intermediate ports, major and minor ports. And it is very important route for the shipping from Indian Ocean. Anybody wants to go from Japan to Europe or Korea to Europe, they have to come through Indian Ocean. Maybe this century, maybe next century, they may prefer to go in the Arctic. But now this is the Indian Ocean is the very important route. So almost all the ship goes through Indian Ocean, especially just south of India. And it is the only region where the tropical region, there is rich biodiversity. The flora and fauna available in this region is so rich, so that we don't know yet how many flora and fauna available. So we need to map them. And also we talk about the food fisheries. We have 1% of GDP of countries comes from the fisheries. So our objective is to how to go from 1% to 2%. So what are the methods that I will discuss later? And also energy. Also we have various kinds of energy, and there are about minerals and also water and also trade, as I mentioned already, trade and tourism and recreation. Of course, all these you can harness, but we need to have an environmental friendly as well as sustainable solution we need to do in order to keep our ocean intact for the future generations. I always think about the future priorities in anything. If it's about 5 things: number one, energy; number two, water; three, food; then health. Health of the human as well as health of the ecosystem, both together, health. And all these 4 components, how it is changing over the warming world, especially when the climate change is shifting, how it is changing. So these all 5 components, you cannot think about without the ocean. How do we get water from ocean? How do you get energy from the ocean? How do you get food from the ocean? How do you get health aspect from the ocean? How do you use this health of the ocean system? How do you intact like a coral, mangrove, all these things? How do you intact, you keep it? But these are all changing under the warming climate change. So climate change is also very important. Now you talk about anything, it will be under the climate change. So that's why these all 5 components, we need to closely look at it. So I will just briefly summarize about each one component where we get it. Suppose you talk about food. Actually, food, basically, as I mentioned, that we have 1% of GDP comes from the fisheries. And mostly Indian fisheries are restricted to our territorial waters, maximum some more few tens of kilometers. We are not at all going for the deep sea fishing. I think we don't have, first of all, policy. We need to develop a policy for deep sea fishing so that we can go for deep sea fishing. And also we can have for maybe aquaculture, cage culture, and also we can go for seaweeds and seagrass, and also this fish aggregation device. If you see that in the Google map, you can see China almost everywhere FAD, that means fish aggregation device. That means you don't go to catch the fish, you invite the fish to come to your place so you can catch. So you can develop a fish aggregation device So that's what there are many opportunities are there to develop the fisheries sectors to go for double the growth of our economy instead of 1% of GDP to 2% of GDP, and also mariculture. But what we need to do is of course, the policy change, and there are many other aspects we need to change for the fisheries aspects, so that we can have a better food. Because when we have the population, everything is increased, so the protein is available is become difficult. So this is the only source we can think of, both the what is called fisheries as well as the maybe the seaweeds and other things. And for this, towards this direction, as you all, many of the people knows that in case Hyderabad, they produce the fisheries potential fishing zone information. That means you know that India has launched one of the unique satellite of OceanSat. From that, they find where the chlorophyll is available. That means food for the fish where it is available. And also from temperature, they understand where the temperature is conducive. That means where conducive temperature for the fish. So if you know both the places, then you can identify where the fish aggregation will take place, so that you can communicate that information to the fishermen, so that they can go and catch where they can go. So instead of searching here and there, they can go straight at that location. So this service is going on from last 1 decade, more than every year they are trying to improve, but now they are going for the species-specific forecast. Even now feedback says that fisheries is okay, but we want to have a specific. Suppose I want only tuna. So now we are making a measurement and other thing. We are what is called tuna. Many of the tuna we have tagged it, and why there it is going there. What is the mechanism? It is aggregating that location. So all this experiment they are doing. So now they will come out with the species-specific forecast. So that will be very helpful, so that both time of the boat as well as the fuel will be saving in these services. And also one of the other important thing is when you talk about the food, the Southern Ocean. Entire biomass of the global ocean, more than 60% of the biomass is available in the Southern Ocean. But the Southern Ocean, nobody is going and nobody will. The main food that it may be, whatever the biomass is available, it has been taken by the Antarctic krill, they call, or toothfish. These two are very, very important species. Of course, the Antarctic krill is main food for the Antarctic penguin and other things. But this availability is huge. But at the same time, this is only possible, only few countries have a fortunate to how and do fishing. So only 29 countries can go Antarctic Treaty consultative status. Those country has, they can go. India is fortunate to have consultative status in Antarctic Treaty, but unfortunately, so far we are not utilizing our quota. But here quota system is there. So our quota we are not at all utilizing so far. Why? Because the investment is required very large. Maybe the big industries has to come, because it is when you go to Southern Ocean, you have to go and you are allowed to maybe make only few thousands of tons of fish you can catch, and you have to process on board, and you have to get the processed one immediately. From there you have to export. And also many of the people, this grilled fish is used for omega-3. The omega-3 is the highest is available. That's why if you go to Australia in Hobart or South America, or you can go any of the southern latitude, anywhere if you go there, you will get omega-3 packets, mainly because of these grill fisheries. So we are not ventured, but at the same time we are importing the grill fisheries waste from many countries, especially Norway and other places. Why? Because we want to put that grill waste into our aquaculture, wherein we get the omega, the aqua, whatever the fishes are getting, that prawn and other thing, it will have omega-3 will be higher. So that's why we are importing the grill fisheries waste. Even though we have quota there, we are not going, but we are importing grill fish waste and we are putting into our aquaculture form. So I think we need to go for large investment in this Antarctic waters, where we have a quota, and every year we can get some of the fishery resources from here. And second thing is, after food, I was telling about energy. When you talk about ocean energy, there are multiple sources are available. You talk about tidal energy, you talk about solar energy, so much solar energy, and also you take a salinity gradient. You have wherever the river meets the sea, so you get to see salinity is about more than 35, 36, and the fresh water is almost zero or even few PSU. That gradient, if you have a 20 PSU, you will be able to generate electricity through osmotic pressure. So that is salinity gradient energy. And ocean current energy, as I told, that East India coastal current as well as West India coastal current, where there is a strong currents, you can put inside there is a turbine so that you can get the ocean current energy. Ocean thermal energy, this is, if the surface of the ocean is about 30 degree, and if you go about 1 kilometer, 2 kilometer, 1.5 kilometer around that, you will get about 20-degree difference temperature. If you have 20-degree different temperature, you can produce electricity. And also you have wave energy and offshore wind energy. Many of you know that yesterday, Cabinet has approved for 0.5 gigawatt, one in Tamil Nadu and another 0.5 gigawatt, one in Gujarat. So these two 1 gigawatt power from the offshore wind energy will be generated from outside resources. So there are many resources are available. So we are now estimating what is the resource available. First, we want to know what is the total energy available. Out of that, how much technology is feasible to harness. Out of that, how economically viable. So these three things we are now working out. What are the energy resource available and technology resource available apart from developing the technology. So we have rough estimate we have done. Of course, in each state wise we have calculated. If you do it, rough estimate is suppose ocean thermal energy. You can say that about 48%, roughly about 1.8 terawatt, sorry, 1.8 petawatt, 1.8 petawatt of energy, we can get it from our EZ of India. Similarly, winds, waves, saline, and tidal currents. Apart from that, because this is out of scale of this ocean solar panel, why we cannot keep in solar panel over the ocean? Nowadays, solar panels are available, wave rating solar panel. So we have everywhere is that we can put alternative box. Of course, sunlight has to go like a chessboard type. You make a grid of solar panel so that sunlight also will go at the same time. Other places you get the energy. So we can put a lot, any amount of energy. If you roughly calculate even that one, that means half of our EZ area, if you put it, you will get about 913 petawatt power available. So why we cannot do this type of energy? So we have to have various kinds of energy. Of course, there are technologies available, and some of the things, even technologies available, we don't have what is called economically feasible. But if you go for larger, then definitely I'm sure that economically it will be feasible. And also we can have hydrocarbon, though we are getting very oil resources, very little in offshore Bombay as well as in east coast of India. But there are many hidden resources. You may be knowing that, of course, these are one of the CSIR lab and NGRA and NIO has been contributed to this hydrocarbon. The hydrocarbon is so rich, so much available in the Bay of Bengal, but unfortunately, we don't have a technology to harness. Even 10% of the what is called gas hydrates, if you take it, that is enough for even 10 years for the country like India. That much rose it is available, but unfortunately, we don't have a technology to harness this. So we need to develop a technology. Nobody will do for this type of things because the resource where it is available, they have to do. Somebody will not do and give it to us. So we need to develop our own technology to harness this hydrate. So that is another source from the energy perspective. So then the third one is a fresh water. You know, there is a desalination plant. It can produce the fresh water. And there is, India has developed a unique desalination plant. It is not like the other one, like reverse osmosis. Reverse osmosis problem is we are bringing the salt brine into the country, wherein it will be degrade the entire land. So in long run, it is not good for having the reverse osmosis desalination plant. So this particular plant is very simple technology. Basically, surface water is 30 degree. It will evaporate, water will evaporate at 100 degree. But what you do is at atmospheric pressure, you reduce the pressure so that the 30-degree water will evaporate. Once it evaporated water, you condense with the subsurface water of cold water, then you get a fresh water. So we have developed such a plant in Lakshadweep. So roughly about 8 plants, I think, 9 plants we have already established of 0.1 million liter per day. And now we are looking at it. Okay, once this the surface water you evaporated with low pressure, that evaporated water will have a high force. So now that force you channelize, you put a turbine so that you can produce electricity. So now we are developing, of course, the pipe diameter is 2 meters and it has to go 1 kilometer deep in the ocean. So now we are developing about 650 kilowatt of power from this each one. We are developing the uh, energy now. So in the same plant, we are getting water, we are getting energy, and now we are looking at another important aspect is ecosystem. The ecosystem is basically when you are taking the surface water and subsurface water. So you are mixing somewhere in the mid depth. Now what is happening? Subsurface water is having a lot of nutrients, whereas surface is having a lot of sunlight. But we have a deficiency in the nutrients in our tropical waters. So when you bring the subsurface water and put it in the surface, so you have more nutrients, so the more productivity will happen, phytoplankton and other things. For that productivity, fish will come, then larger fish will come. So the entire ecosystem is changes. So by keeping this freshwater plant in islands and other places, so you will be able to change the ecosystem. You get the fresh and the energy can produce not only operate this plant, but also only 30% of the electricity you can use it for the plant. Remaining 70% you can provide to the main grid. So that means so energy, water, and ecosystem. Ecosystem means again it is food. So all three you can get in one store. So that has been already developed. Maybe if some of you happen to go to Lakshadweep, please do visit that. This is a plant. Now it is about 7, 8. Recently, PM has unveiled 2 of the plant before election. Of course, this is a typical plant looks like. And now we are making it to see the ocean thermal energy I was talking about. I don't know, I'm not bothered about time. So ocean thermal energy I was talking about. The main problem in the thermal energy is I was telling about the gradient. If you have a 20-degree temperature gradient, you will be able to produce electricity. But island is fine. But mainland, the 20-degree difference, I have to go deep into the ocean. Now the electricity if I produce, that to bring, it is more cost. So that is why it is very difficult. So now we are thinking, can we have a barge type of things, produce electricity and fresh water in the barge. Once you have a fresh water, you have electricity, can you convert into hydrogen and store it in the below the ocean with the buoyancy? Whenever you want, you can bring it and use it for your main purpose. So that is we are thinking. So now we are going for a pilot project to produce water, energy, and hydrogen. These are the 3 combinations we are looking at it in pilot scale. And also it is also very important because the ecosystem we keep on sustainably as well as we are using the ecosystem improvement, health is improving. That is more important than other things. Of course, you know that now the ocean, not only that, in the future, all your computer system, I am think you name it, any HPC will be below the ocean because the exchange of heat is so much. So why you want to keep the computer on the land? Why don't you keep to the sea surface? Maybe at 2-degree temperature. Only you have to protect well. That's it. So now many of the even now Google has started putting in 1.5 kilometer deep in the ocean. All their storage, everything is below the sea, so that there is no heat. Now, for example, next month we are going to install about 20 petaflop computer in NCMW in Noida. For that, of course, it is about 1,000 crore. But for that power, what we need is about at least 10 megawatt power we require. But 10 megawatt power, and if only for heating the computer, we want to have a cooling. So we want a cooling. For that cooling, we required about 10 megawatt power. It is huge power. So now, why we have to use? Why not use it to the subsea? So future, all the cloud, so-called storage and compute device will go under the sea. I'm sure that we need to go in that direction as well. And the fourth component, I'm very much important, which in the ocean provides us is the minerals. As you know that minerals in the most of the three dominant, one is a polymetallic nodule, it is PMN. Another one is a polymetallic sulfides, it is a multimetals, and the cobalt crust. All these three areas, of course, it is outside EZ. Our EZ resource, we keep it later. But outside EZ, how fast we can harness, that we need to harness. Of course, now we are only doing the exploration. Still, exploitation rights are not available because we need to prove that environmentally it is safe. Until we prove that internationally, we cannot go. So now we are under testing we are trying to grab some metals and try to see how much we are degrading the environment. That we have to prove internationally in United Nations. Once we prove, of course, all the countries, they are doing same thing. So now once we prove it, we can harness the metal. But we know how much is available, resources. Similarly, the polymetallic sulfides, where it is available, that resource for finding and identifying itself tough job. So recently, we are able to identify few of the hydrothermal sulfides in the last month in the mid-ocean reach of Indian Ocean, where an international seabed authority has contracted to India about 3,000 square miles. So now we are going for new sites to make it in the cobalt crust in the Arabian Sea. Of course, NIO has already put a claim in the International Seabed Authority. Maybe I'm hopefully by next month we will come to know how much area they will allot to India. And also we have hit cobalt crust, and you may be knowing that most of the stories what you are hearing cobalt crust in the newspaper. So that is a lot of disputes are going between the countries. So we want to climb that area, but there are other countries are supporting. And of course, this is geopolitics. That's what I was telling. It is a lot of geopolitics and geostrategy. We need to work on ocean sphere. And this is what I was telling that is that we have 2.3 million square kilometer, but at the same time, we are also going for continental self-extended. Continental self, we are going to climb from the from the continental self, from the UN, roughly about 6 million square kilometer we are going to get it. So this is based on, you prove that the sediment available at that beyond your EZ, that sediment thickness, if it is more than some number, that means more than a kilometer, that sediment belongs to your country, you prove scientifically, then you will be able to get that area maximum up to 350. So the shaded area which I have mentioned here, so in the Arabian Sea and this area as well as this area, we have already climbed. So now we are going on various kinds of discussion and proving scientifically how the sediment thickness is available, where it is available, and to what depth, what is the distance available. All these things we are proving. Last 2 years we are going UN and we are we are putting our climb, and it is going on this one. Of course, as I mentioned that in this PMN we have a copper, nickel, cobalt, and manganese, and it is also very important that we need to know once we bring the metals whether we know how to separate the metal. And we are fortunate to have India as one of the unique country that we are able to, IMMT, CSIR is able to develop the metal, how to recover the metals from this PMI. So that is very important things. Not many countries have done. That is why in International Seabed Authority, the India is a unique country, is a pioneer investor in PMI related stuff. Of course, the main people who found and all this research has been done by NIO Goa, and now they are able to develop the metal also by IMMT. It is very fortunate we have that technology is available. Of course, there are, as I mentioned, there are two more areas we are last year we submitted. That is, one is cobalt and another one is a PMS. So we will come to know next month about the PMS, what is the result in next July end. And I will go back to other infrastructure. Basically, shipping, there are many infrastructure in ocean. You take optical fiber cable, you take many ocean infrastructure is there, but I will take only shipping for the benefit of time. Of course, there are many ports and other things there. I told you this shipping route is a very important strategic route in Indian Ocean, and but we are not utilizing effortly because we don't have proper port to bring the ship and do service or fuel and other things you do. There are many marine industries are big, so we need to develop that one. And also we need to develop optimum ship routing. Suppose if you want a ship going from Chennai to Singapore, they always go for straight line. But that is not the scientific way to go. Actually, they have to use the waves, winds, and currents. You have to calculate. Based on this, you have to find out the optimum ship routing. Instead of straight line, you can go like this. But your efficiency, that means fuel saving is high, as well as time also will be saved. So that route we have to do online for each ship and other things. Also, as I mentioned, that East India coastal current, you have a current from October onwards, currents comes from West Bengal to south, maybe Chennai. So this route, very strong currents. You put any material, any container, any 5 container, 100 container, 1,000 container, you put in West Bengal, you can get back in Chennai. So why we cannot use this opportunity? In other season, it is other way around. So we need to make a corridor like this. So from October, suppose in November, you want to transport some 10,000 container from West Bengal to maybe Andhra or Tamil Nadu or much below, you want to transport, you use the sea route. In other time, you use the maybe railway route. So we have to make a corridor like this. Similarly, in the West Coast. So we need to plan for optimum ship routing so that we will be able to benefit from much fuel saving. So that we are working on it with the, I think, Ministry of Shipping, and we are also providing various inputs for optimum ship routing and other things. They have already started Sagarmala. So they have already made a quadrilateral ocean necklace they want to create. So now we have to see the ocean side also ocean necklace. So we need to develop the coastal belt, coastal transport system we need to develop in the coming years. And also we need to develop a coastal ecotourism because the tourism industry is very less in India, especially coastal tourism. But we have fortunate to have a lot of biodiversity. I don't know, maybe if you go to Lakshadweep and Andaman, if you see the snorkeling and diving, if you see, it is mind-blowing. But we are not harnessing that ecosystem in terms of tourism. We have to see, we have to educate the people, the various species available, and all the system we need to show them. And we need to develop the coastal ecotourism in the coming year because this is very untapped. And also we can have in a country, such a big country with an ocean country, we don't have oceanarium. I think we need to develop a big oceanarium, one in East Coast and one in West Coast. And also we have to blue black features, we have to make it. I think MOEF has already started blue black certification already they have started. So more and more it will come out. And also we don't have any geo heritage park. We don't have policy to declare a geo heritage park. So we need to make a change a policy to make a geo heritage parks and other things. So we need to develop in such a system so that we can have South Asia. This is the best destination for the coastal tourism that we can think of it. That's another ideas. Then the marine trade and services. This is also very poor. There are marine industries. We don't have marine industry. Even if you want to go for fish net, you have to go for Japan and bring it. We are not doing any marine. Even on boat, we want to construct. We have to get these maybe the components from other countries. We are not producing anything. So we need to develop the manufacturing sector, especially the marine manufacturing sector all along the coast. We need to develop. Until we don't develop, we cannot make this shipping and other things also grow much more. I'm sure that in Karnataka already they are developing a big port and other things. So that will be definitely, it will fetch a lot of leverage. And also we need to develop ease of doing business for the marine sector so that we can produce services, especially coastal industrial services we need to develop. Then the blue biotechnology, mainly marine biotechnology, what are the things are available, algae or whatever the whether we can do drug from sea. So that's the thing. I think biotechnology department is talking about a bioeconomy and other thing. Where is the bioresource available? It is only available in the ocean. So we need to think about macroalgae or microalgae. All these algae we have to develop, seaweeds and other things. We need to go in the ocean. We need to sea ranching. Everything we have to do. Then you can feed to bioeconomy. Otherwise, it is very difficult to get from the land resources, bio waste and other things. So this is one of the macroalgae from the seaweed is one of the important resources for the bioeconomy as well as blue economy. I am sure that many of the CSIR lab from Bhavnagar and other institutions are working for seaweed and other things. It is very important. We need to go for a massive scale. Also, deep sea we have to go, not only coast. And also maritime security as well as international engagement. I think we need to ocean space is the only ocean is Indian Ocean is India's name. So we need to be truthful to that. For that, we need to be a leader, a global South leader, so that we need to entire Indian Ocean Rim countries. We need to support you in the IOR, the Indian Ocean Region Alliance. We need to be a big player, and we need to take care of all these things needs, and we need to play a strategic role. And geopolitically, we have to win over other countries, those who are coming in Indian Ocean region. So we need to play a strategic role, international engagement we need to do, and also we need to secure ourselves in the underwater domain. We need to have a more knowledge where we need to park our submarines, where we should not park it. Everything we should know unless we don't know the sound velocity or mapping the sound profiles of the entire coast. We will not be able to secure our nation. So we need to have more and more observations in this domain. And of course, we need to do a lot of innovation and R&D and technology adaptations. So under this only, of course, these are the various opportunity, but the investment in R&D is one of the pilot project is the deep ocean mission for 5 years up to maybe 3-4 years for the 4,000 odd crore. But this is a pilot project to demonstrate various technology and other things. Maybe I will I will go deep ocean mission. What are the 6 verticals? Just to I'll pinpoint. So essentially, we need to develop a technology, as I was telling about ocean energy, ocean water, food, as well as methane, gas hydrates, all these things, how to harness that we need to develop a technology. And also polymetallic noodle is available. But commercially, how do you pump it to the 6 kilometer to the sea? You need to develop a technology. Still, we don't have proper technology. Nowhere in the world is available, but we are in a much better stage than many countries. So we need to race for this. And also we have to do new insights, that means new understanding. We need to go for observations. And also we need to develop various products and services for the ocean realm. And as I mentioned that we need to develop human capital. That is more important because human capital for ocean people are hardly very less. The amount of people, if you compare ratio, any ratio you take it, total number of people available and working in the ocean, or internationally, how each country you map, and we are the least. Even CSIR itself, how many lab is working? Only one lab is working. And maybe many. I think we need to develop more and more human capital for ocean sphere so that we can have a better science, better knowledge, as well as we need to have a technology more and more. And also we need to have a develop accounting framework. As you know that roughly if you take about all together about 4% of GDP comes from the blue, from the ocean sector as of now, presently country like India. But it is our objective to how do we push this 4% to 8%, at least double digit or 8%. That's the objective. For that, what are the things we need to do? We need to various kinds, whatever I mentioned, that we need to go for it. For that only, we need to develop a mechanism in India to go for a blue growth. So this is basically, we need to have an accounting framework. Of course, the Ministry of Statistics and Planning already working on this various aspects, not only for economy, but also carbon budget and other things, how mangrove is contributing to carbon budget, as well as how the economy is coming from the blue. All these things they are working out in the Ministry of Statistics and Planning. And just to quickly summarize to 2-3 slides about the challenges, as I mentioned about non-climatic stress, as well as climatic stress, as well as there are other challenges. We need to have a resource mapping. We don't know what are the resources available, where it is available. We need to hunt. So that is one thing we need to do, and also we need to develop a technology, and we need to have a mitigation measures, mitigation mechanism for the cyclone, tsunami, or plastic pollution, or any other natural hazards originating from the ocean, or it is a man-made stress which we are creating in the ocean. How do we mitigate that? We need to develop, and also we need to develop various policies, either fisheries policy, or blue economy policy, or marine litter policy, various policy we need to develop, and also we need to build a security measurement more. And there are other challenges apart from non-climatic stress like natural hazards, marine litter, oil spills, and other things, and climate stress, whatever I mentioned. So these are the various kinds of sea level rise. It is a threatening, but we need to think about how do we safeguard. We cannot do because ocean is one ocean. Anything happen anywhere, it will affect other people. So we need to have a mechanism not only to understand, but also we need to have an adaptation methodology, what we need to do. That is more important. And the marine heat wave, the new one, like what heat wave we are seeing, you know only about 48, 49 in Delhi, but you don't know what is the Bay of Bengal is happening. The heat wave is happening in such a way in Bay of Bengal, no fish will come to the surface. The stratification is so strong, so heat, all the fishes are down below. It never comes up. So the marine heat wave, if it is increased, so then fisheries production will be very, very low. So that is another consequences. We need to know what is the mechanism. So one of the estimates is telling the projection says that now it is roughly about 20 days per year marine heat wave is happening in the Bay of Bengal. Maybe in the what is called IPCC projections, if you calculate from the Bay of Bengal, it is roughly about 200 days per year. Out of 365 days, more than half of time it is marine heat wave. If it is so, then why fish surface? So marine heat wave will produce strong stratification, so thermal stratification. So nothing can dive. So it will be a big problem. So we need to think about coral, mangrove, and acidification. The carbon, whatever we are putting, carbon dioxide, it is sink. That's fine, but how long it can absorb carbon? Then it will convert it into acid. Then it will be acidification. Once it is acidification, then the calcium growth and other thing in the ocean, it will become depleting. So there are other consequences will happen. So these are the various challenges we need to tackle. So we need to understand as well as the technology and other things we need to invent. And this is again coastal hazards. You can say that storms, floods, coastal flooding, and associated storm surges, how much it is happening, storm surges, we need to forewarn. Of course, now cyclone, we are able to better forecast than many countries. So similarly, we need to forewarn various fast moving like storms and other things, and also slow onset hazards like coastal erosion, seawater intrusion, because that is another problem. It is not only sea level rise is a problem, but the water table also will be salty. So that is also another problem. So we need to have, and also land subsidence, another consequences. So all these things we need to have a mitigation mechanism in place. And just to tell about Indian Ocean, as I mentioned already, Indian Ocean is warming about much faster than any other ocean. It is going about 0.12 degrees Celsius per decade. If you take about 1950 to 2020, but it is expected to double, maybe 0.17 to 0.38 degree per decade in the IPCC projection, roughly about in 2100 in the 21st century. Similarly, ocean heat content, that is not only surface, the entire ocean heat content up to 2 kilometers, it is warming up. And that warming also, it is huge in the Indian Ocean. And the marine heat wave, as I mentioned, now it is 20 days per year. Now it will become 200 days per year. So all this complexity will reduce the chlorophyll, phytoplankton, primary productivity will reduce, then increase in acidification because of the carbon, and there is an increase in pressure in the total ecosystem. So these are all some of the challenges over and above the marine litter, which we are pumping about 0.6 million metric ton per year. We are putting into the ocean, not only from the land based, but also the ocean based. Ocean based means mainly nets and ship and other things. So what is the way forward? So we need to understand better. For that, we need to observe the ocean, both in situ and satellites. And we need to go for more and more observation. not only at the surface, at subsurface. Underwater domain is important, we need to understand. And we need to plan coastal marine spatial planning. We need to plan our coastal, where we need to build the industry in the coast, where we should not build the industry in the coming years. We need to plan. Like a town planning, what we are doing, we need to go for coastal planning. Until we don't have a planning where we need to construct the port, where we should not do. We should know now we have to project and we have to plan. Similarly, we have to explore and identify the resources where it is available, various resources, not only living but also in the non-living. And we need to develop a technology. We need to harness ocean resources sustainably, and we have to have a mitigation mechanism. And we need to develop most of the things on ecosystem-based solution or the services. So once we do this, then we can bring out a clean ocean, healthy and resilient ocean, a productive and predicted ocean, safe and accessible ocean, and inspiring and engaging ocean. This is what the main objective of the decade of the ocean. So we need to attack this particular component. I think for that, we have developed the vision statement. This is a sustainable utilization of ocean resources for economic growth of the country, ensuring health, safety, and diversity of the ecosystem. Basically, blue economy policy will come out soon. And blue economy is nothing but ocean economy plus sustainability is blue economy. So we need to go for blue economy policy that we will roll out. The main deliverable in the blue this objective is the blue economic growth, that means GDP or cross value added TVA, whatever this one, we need to have a double or double digit or double, we have to go for it. For that, one ministry cannot do anything. So we need to have various ministries. We already work with the 12 ministries, right from MOEF, MNRE, shipping, fishing, Ministry of Statistics and Planning. So all about 12 ministries put together. So it is like a Gati Shakti. We have to give a Ocean Shakti. We have to do some of the interministerial collaboration whereby we can work together and we can make a implementation of the blue growth. Of course, for that we need the science-based decision making and also mitigation of marine hazards. So for that we have made 8 pillars. Each ministry will look after mapping, planning, harnessing, infrastructure, security and international innovation, human capital, and accounting. All these 8 pillars, various ministries, about 12 ministries will work together for these 8 pillars so that we can bring out some of the blue growth. So what we need to do is, basically, as I always feel that ocean is our future. So food, water, energy, health, and climate change and security is all this aspect is ocean. We have to depend on the ocean. For that, we need to monitor, we need to understand better, and we need to model, and we have to predict, and also we need to develop a technology and other things. I think together we need to accelerate modern research, innovation, and technologies in the ocean realm. With this, I thank you once again for all of your time. And I'm sorry I have taken more than what is required. Some more slides. Sorry. Thank you very much. If you have any questions, I'll be very happy to answer. Yes.
Utilizing gas hydrate for energy and chemicals. What are other challenges of exploiting the gas hydrate for energy and other purposes, apart from the technology?
Yeah. So actually, this marine, see, in the gas hydrates, whatever it is there, around that there are many flora and fauna ecosystem is there. So any resource from the ocean, if you are harnessing, you have to prove yourself how safe it is. That we don't know. We don't know. I think NIO, many people are working on it. What are the flora and fauna nearby gas hydrates? If you touch that, what will happen to them? So that flora and fauna is dependent on gas hydrates. So that we have to understand better. But as of now, we don't know. We have to study. Even polymetallic noodle, what I'm telling, still we don't know. Even though we know how much energy is available and how much metals are available, but we don't know what are the environmental impact which will happen. especially flora and fauna. We don't know. We are making it measurements. We are artificially triggering it and try to see what is the environmental degradation we are doing now. So like that we have to do for gas heritage. Maybe that is a second stage because even technology itself, what is available, we are not knowing environmental proof. So as of now in the ocean, there is no, you cannot take the metal or even energy for that matter unless you prove environmental impact of that particular areas, species. And
So, good evening, sir, and as usual, very, thought-provoking and exhaustive kind of talk that you've given. But my one comment that I'd like to make it, I wish, ma'am, the MOES secretary would have come to CSIR headquarters earlier, because before his lecture we got very good showers outside, and it's cooled down. So thank you, sir. I think you brought the rain to Delhi.
no, very short term. I told you atmospheric memory is very short. You will get back very soon in few days.
So another thing, sir, I mean, just, as a forward thing, there are many predictive models for, monsoon and also for all these, the temperature and the weather forecasting. And I know over the years, IMD has done a tremendous job in, making these models more and more accurate. And yet we see many a times, when rainfall is forecasted, we don't get rains. So what more needs to be done? And as you said, this is not just one ministry that can do everything. There are many agencies that have to work together. So I just wanted to know if you could highlight what more needs to be done in this case.
Yeah.
So maybe, as CSIR, we could take up a mission mode program in this particular thing as well.
Yeah, that is what my next mission is. Atmospheric mission that is called Mission Mousam will come very soon, and it is a very big mission. So now, what is the thing is, see weather. If you talk about monsoon forecast, earlier maybe 10 years down the line, we are only forecast with the statistical parameters. Here, if it is temperature more, here it is snowfall is more, or here it is something. If it is there, you will get better monsoon or bad monsoon like that. But we are all only talking about 10% plus or minus. But recently means a decade ago, we are able to start the model as a dynamical physics-based model. That means ocean atmospheric coupled model we started. Now that model also, we have a lot of assumptions. Okay, because still we don't know what are the processes, how the energy as well as the what is called flux. That means moisture flux, how the ocean is transporting to atmosphere, how the atmosphere is transporting to ocean, both the heat and mass, we are not very well understood. We need to understand better, of course. Now we are able to make a numerical, physics-based numerical model we are forecasting. But that we are able to forecast only, maybe I can say that 70%. That means if 700 times, if I tell only 70 will be success. Okay, but 30 where you are going wrong, even though physics based, because we are assumptions, because all the meteorological problem, initial value problem, initially how much error you are doing, that much error will grow. So the remaining 30% we are not able to attack because we don't have observations. We need to have what observation we have. We should have almost twofold increase. Now, if I have one observation, I want to have at least 100 observations. So observation has to be huge. We require observations. See the temperature, temperature, humidity. These are the two traces. How these two variables changed over by wind in the atmosphere. We want to know how it is changing. Similarly, in the ocean, temperature, salinity, and current, how it is varying, and how these three variables talking each other. This is only I'm talking about physics. It will give only result only 70% again. Then again, if you see biology, how the biologic biomass is there, how it contribute to temperature, that contribute to again atmosphere, then aerosol, how contribute to heating, then how it is. So we have only primary method. That is major thing 70%. So in order to go for better things, still improve. We want to improve more and more. We need to have more observation, and also we are thinking about more observations and more, not only physics-based model. We need to have a data-driven model like AIML, and we are working on it. Maybe another 5-6 years, we will have a Mousum GPT. I am sure we will have Mousum GPT. What I mean is, Mousum GPT means you have a GPT, you have all the information. Similarly, now I will develop a GPT based on all the weather info. Suppose even farmers tomorrow, if you want to go for it, whether I can sow, he has to go from GPT. So that level we are going for, that Panchayat level forecast we want to go for it. So we are planning to go for at least one aircraft by at least 2 satellites, at least what is called wind profiler. Entire country will be radar with radar available watch. All these things we are planning about maybe few maybe 20-30,000 crore. We need more. That's it. So that will happen soon. So once it is available, it may be possible. Even I cannot go for 100. If I 100%, if I didn't, if even 95%, if I have done, I can shut down Meteorology Institute as well as oceanography. All these people I can shut down because we know everything. You are asking just like, can I get cancer next month, next year? That is what. See, we are working at a. We are maybe small doctors for the Mother Earth. How much you know in the body, similarly in the Mother Earth is huge, and the interaction of energy is huge. So we need to understand means we need to observe more and more. So if you observe more and more, you will be able to understand better. If you understand better, you can incorporate in the model, then you can improve the better forecast. Thank you. Yes. Yes, in India we are not thinking of floating city, but there are in Europe, especially many countries, especially in Amsterdam. It is one of the first attack. It will be attacked by sea level rise. So now they are going for the floating buildings and cities. So maybe that much level we are not, because still there are low hanging fruits are there. After that we will go for that. Yeah. It is not a simple answer. It is a descriptive answer is required. So that's what I, in simple way, if you want to say, that is a geographical setting in India was placed like that. So that is a, suppose if you would have been northern side is open, like Pacific, whatever heat available in the tropics, it goes to polar region, then it is coming down, then again it is a circulation is there. That ventilation is not available here in the Indian Ocean. And also it is a, basically it's a geographical setting of the entire global earth in our region, how it is setting. So the physical process changing, Himalaya is helping. So it is winds are going there, cannot go beyond. So there are many things are there. That's why it is reversal of currents as well as reversal of winds are happening only in North Indian Ocean.
Yeah. Yeah. Hello. Thank you for a very informative talk. A couple of questions, very abstract kind of questions, nothing defined. I was wondering that our neighboring country like China, which we share the same ocean with, has a pretty good development in terms of port and harvesting things from the ocean. So I was wondering, in terms of sustainability, do we have any data comparison? If one were to be that developed on the coastal line, what are its implications, wherein we are not that developed at this point, right? So can we learn something from that? And second thing is, do we have the landmass which is of that quality to develop the port without sacrificing good areas? I mean, can we develop port in places which otherwise cannot be used for any other purposes?
Yeah, okay, second question first. Yes, we have already identified which are the area that cannot be degraded even if you do some of the construction work in coast. So that area we have already identified. It is possible to identify. Some area it is very vulnerable. Even if you touch little bit, not only that area, even northern side and southern side also, it will be eroded. So we need to understand that. So we have, yes, there is a place for that. And the first one is actually this is a China is not very what is called the amount of knowledge what we have. I don't think oceanography they don't have that much also, but they have money. They can do. Suppose you construct one port, they can construct 10 port. That's the only thing. But otherwise, of course, there are some of the other areas they are better than us. But it is when we have to compare, we should not compare China. There are many other countries, better countries are there to compare, so that we can grow better. That's what I feel. I don't know. First question I have answered well. I don't know, but yeah.